Hello everyone and welcome back to Calculus. First, I'd like to thank all the nice people that support this channel by liking and subscribing. In the last video, we finished all the differentiation rules, which include the power rule, chain, product, and quotient rules. Now that we have all that skill under our belt, we can finally apply it to find two different things: the tangent of a curve and the normal of a curve. So let's immediately visualize this on the graph. Please recall from part 3, we used the first principles to determine the slope of a curve at a specific x value. Most of the time, we use a short straight line to show the slope. Funny enough, if we were to extend this line to infinity on both sides, we would get a linear function with the same gradient as the curve's gradient at that x value. And this red line here is called the tangent of a curve. It's basically a linear representation of a curve slope at a specific x value. Now, in order to build this linear function of the gradient, we need one formula and three of its components. This right here is the formula for formulating the equation of a line. And the three components we need are y0, which is the corresponding y value at the x point which we are evaluating the gradient. M is the gradient itself, or in other words, the derivative value at that x value, and x0 is the x value at which we are evaluating the gradient. So, another way to formulate this formula could be the following. With this formulation, you can probably notice a funny thing. Even though originally we said we needed a formula and three different components, here in the other formulation of the formula, all we need is the function itself given and the x value at which we'll be evaluating the gradient and constructing the tangent line. So in reality, it is not as complicated as you might think. Now that the tangent has been explained, let's move on to the normal. It turns out the normal is actually closely correlated to the tangent, because the normal line also goes through that same point at which we evaluate the gradient and the tangent line. The only difference is that the normal and the tangent are perpendicular. That means they formulate a 90 degrees angle with each other. So in reality, constructing the normal of a curve is the same as the tangent. The only thing that changes is the gradient. If you know a lot about linear functions, you could probably know that if two lines are perpendicular, their slopes are negative reciprocals of each other. This means if our tangent line possesses the gradient m, then the normal of a curve would have the slope 1 over m negative. What we did here was add a minus sign in the front and then flipped the fraction. Logically, 1 over m would simply equal to negative m in the sense of negative reciprocals. Alright, so now that the theory is out of the way, let's immediately look at two different examples. We are given the function f of x equals to 3x squared minus 1 over x plus 2. In this case, x does not equal to negative 2, and we are asked to evaluate the equation of the tangent and normal of the curve at the point 0 and 1. Please note that the point at which they ask you to evaluate the tangent and normal are the points x0 and y0. If the y0 value wasn't given originally in the question, then you can always just plug in the x value into f of x and you would get 1 out. Or in general, you would get the y0 value. Here, the first step would always be to compute the derivative of f of x. Unfortunately, in our case, we do not really have a choice other than using the quotient rule. Here we can immediately simplify this derivative. Okay, so now that we have the simplified version of the derivative, all we need to do is to plug in x equals to 0 and evaluate it there. And we would get 1 over 4. What we get here is the gradient of the tangent of the curve. So now that we have all three components, x0, y0, and the gradient, we can construct the equation of the tangent line. Please remember that the equation of a line must always look in the form of y equals to mx plus b. So in our case, that would simply be y equals to 1 over 4x plus 1. And this right here would be the equation of the tangent. Now they also asked us to construct the equation of the normal line. And the only thing we need to change here is the slope. So if the slope was originally 1 over 4, and we know that the gradient of the normal is its negative reciprocal, the gradient of the normal would simply be negative 4. Once again, rearranging it into the form of y equals to mx plus b, all we have is y equals to negative 4x plus 1. And here we have found both the tangent and the normal of the curve. So now let's take a look at another example where the points are not given, but the gradient is. Here we are given the function f of x equals to x cubed minus 5x squared plus 5x minus 4. And it is said that the gradient equals to 2. And now we need to find the equation of the tangent and normal to the curve. Once again, our first step would be to evaluate the derivative of f of x. Using the simple power rule here, we get 3x squared minus 10x plus 5. Now it is given in the question that gradient is equal to 2, which means our derivative will be equated to 2, and we need to find the x value. Moving the 2 from the right to the left, we get a quadratic equation. Here you can solve this in two different ways. I like to use the factorization method, however, that does not always work for all quadratic equations. Alternatively, the most common method is using the discriminant. Here with factorization, I get that x can be equal to 3 or x can be equal to 1/3. Now it is completely normal that we get two different x values. This just says that on the curve at two distinct points, the gradient is equal to 2. And this can happen actually quite often. So now all we need to do is find the corresponding y values of these two x's. And we do that by plugging the gotten x into the original f of x. Here I skipped the calculation and got y1 equals to negative 7, and the other y value is negative 77 over 27. So now that we have two different points and the gradient already given, we can construct two different tangent lines. And here we get the equation of the tangent y equals to 2x minus 13. And the equation of the second tangent line would be 2x minus 95 over 27. Similarly, constructing the normal of a curve would be in the same way, however, the gradient would be changed. And the gradient of the normal curve, according to the negative reciprocal, would simply be negative 1 over 2. So I will leave that to you and leave the answer on the screen. Logically, there are also two different normal curves. And this here would be the two normal curves. Perfect. So now that you know how to construct the tangents and normals of a curve, we will move on to maximums and minimums in the next video. So I hope to see you there and have a nice day. Bye.